Hi, Monique and Brady.
Hi.
We've got Brady Bob, we've got Benny Mac, we've got Hamish, we've got Ange, and this time we've got the microphone on so you can hear everything.
Wait, should we check if it works?
No, I turned it on. I'm sure it works.
Okay.
All right, so we're up to find the stationary point on the curve y equals 2x to the power of 5 minus 3 and determine its nature. There's a big clue there with the word point. There's only going to be one stationary point. We know with a power of 5, technically a quintic, we can have up to 4 turning points, but not this one. There's only going to be the one. So, first step, we differentiate. Because this curve is y equals, I'm going to use the same notation. First derivative will be y dash, and I'll get 10x to the power of 4. Now to find stationary curves, we put the first derivative equal to 0. Sorry, stationary points. Okay, for stationary points, y dash equals 0. So 10x to the power of 4 equals 0. And that leaves us with x equals 0. It's also very convenient to substitute that value back into the original equation to find the y coordinate. So when x equals 0, y equals negative 3. So 0, negative 3 is a stationary point. Now we've got two options to find out what sort of stationary point it is. We can check that the sign of the first derivative changes, and we did that when we drew up our little table, but what we're practicing today is using the second derivative to determine the type of stationary point we've got. So we need a second derivative. So differentiating for a second time gives us y double dash, and we get 40x cubed. So when x equals 0, y double dash equals 0. So what we're looking at is a potential point of inflection. But that's not enough. With points of inflection, we also need to check that concavity changes. So we do need to have our x value and our second derivative value. So 0 is the one. So we need to test values either side of 0 in the second derivative. And that's actually pretty easy. Because it's 40x cubed, and we know if we cube a negative number, it will be negative. And if we cube a positive number, it will be positive. That tells us that at x equals 0, we do have a change in concavity, hence a point of horizontal inflection. So we say, therefore, 0 minus 3 is a point of horizontal inflection. And I'm trying to get into the habit of highlighting my final answer. It's probably not a bad idea to start doing that as well.